I will try to allude in these next 10 minutes to these titles in the contents, but much of that will come up also in our plenary discussion, the panel discussion after. We are all familiar with the great risk of fire to the container shipping industry, especially to fully laden ships at sea and in port. Today I'd like to ponder that risk, taking into account the much larger vessels in the modern fleet. We can think about that risk in the light of three recent and widely reported incidents: Express Pearl, KMTC Hong Kong, and Ocean Trader. They and their cargoes were victims of fire. They are not protagonists. They and other images are here only for illustration. Many are acutely aware of past and current trends and issues, which frequently foretell of disasters to come. Of great assistance when trying to get a message across is visualization, actual events. These three chosen vessels provide that service to me now. Imagine each in a major port or terminal, with ships made fast either side and opposite, with vast terminal storage only a crane's length away, with, at the most, 2 or 3 fire engines on site, and, at the most, 2 or 3 local public fire service vehicles a full 10 minutes ride away, and backup that is much further. Now imagine a 23,000 plus TEU ship. What is the scale up? Express Pearl was not fully loaded. A 23,000 TEU vessel is more than 8 times the size. That is 8 times the fire loading, 8 times scale up. In fire is beyond imagination, and it is also beyond effective control. I talked about visualization. For Express Pearl, the visualization there on the image you can see is the radiant heat. Radiant heat from a fire is an extremely significant part of the process in fire spread. For KMTC Hong Kong, the visualization is its explosion projection. Look at the height of the burning projectile on the left image there. It is higher, significantly higher than the length of the vessel. There is also port and starboard distribution of burning fire debris. For Ocean Trader, our visualization is explosion and port risk. Note the port starboard fire debris spread here is also the same as the length of the vessel. And that burning debris, as we can see from the top right image, it reached the dockside storage. In yellow on the left image there is an overlay of a 400-meter ship to scale. Note the height. It is not just a question of the increased fire loading and size of the vessel. The height at a dockside also increases the chance of spread and risk beyond current measures. We know that due to the sheer size of the modern fleet, there are problems with salvage and other response services. The same applies to fire. Port infrastructure has not adjusted with ship size changes. Obstructions and increased risk of fire spread must be reconsidered. Now let's look at our visualizations in terms of the Express Pearl and Ocean Trader in a current port. Our visualization for Express Pearl was the radiation risk, the heat of the radiation. On port, at port, that radiation heat will reach current dockside storage. Ocean Trader, we know already that reached the current levels and dynamics of dockside storage. Now let's put these onto a larger vessel, our 400-meter there overlaid in yellow. And the radiation is probably my greatest concern. is absolutely effective and strong enough with a major fire to reach current dockside storage. The explosion risk also will substantially reach that storage. I've not, in that image, actually exaggerated too much. Of course, with an explosion risk, it's going to be one or two, hopefully at the most, containers to erupt. But if they are deep within the fire, they are going to push more products out, port and starboard and above. Let's put this in another port. And here, the dynamics of the port gives a slightly dead-end condition there, which will limit the access for tugs. In this port, the orientation of the dockside storage is end-on to the risk, which in my scenario is the ship. That will make that dockside storage more vulnerable. Fire risk assessment must be holistic and all-encompassing. The risk is primarily the container unit. The container unit has not changed significantly since inception. They are the eggs in bigger and bigger baskets, but each of these eggs is a fire load. Self-sufficient fire casualty, this is a term not devised by me. It is a good term and a logical aim, and it takes us back to the origins of fire and fire safety, which is at sea. But it's being applied only to the ship, not to the container. It is certainly laudable, but it only applies to that certain class, size of vessel, and of course it's not retrospective. Fire solutions, all fire, land or sea, will always use these standard terminology. It's all about prevention, alert, suppression, and containment. It applies to all risks. Solutions at source, in this context, being the container, potentially, the same terminology applies. Prevention, detection, suppression, containment can be achieved in each TEU. We know that the fixes are not easy, quick, or cheap. We also know that there are many organizations and individuals in the industry doing what they can in their own fields of influence. We simply ask that others listen to them and to us and heed the warnings. I asked, are we sailing blissfully to catastrophe? Blissfully? Of course not. That is glib, and I am not so cynical. But there is still significant risk to be addressed, and one key risk is the container itself. To achieve a self-sufficient casualty, this must be addressed. This is where we are, and this is myself. I thank you.